Welcome to Finite Element Analysis Laboratory, Episode 11, 2D Thermal Analysis on a Rectangular Plate by Youni-Learning. Today, we are going to perform this analysis on ANSYS Workbench Software 2020. For this purpose, our objective is to calculate and verify the temperature distribution based on the boundary conditions and thermal stresses and strains in 2D planar specimen using thermal analysis. This will be our specimen, which is a rectangular plate, and we will apply boundary conditions in its specific directions. Our goal is to understand how the thermal analysis is being conducted using ANSYS software. We will verify the law of conservation of energy, which states that energy can neither be created nor be destroyed but can transform from one form to another form in FEA software. We will also try to understand the theory of thermal analysis using rectangular plate as an example. In order to discuss the thermal analysis, we first need to discuss what are the three modes of heat transfer. The three modes of heat transfer, as you can see on your screen, are convection, conduction, and radiation. The flow of heat transfer in each of these modes is different. For example, in conduction, you need a solid medium where the molecules vibrate and transfer their energy, which in the form of heat. In convection, the fluid is air, which is continuous sharing. And the last one is the radiation, which does not require a medium for its propagation. This will be our specimen, a rectangular plate, which will be oriented in 2D. We will only specify the 2D boundary conditions and respective geometry in this analysis system. We will verify the law of conservation of energy. There is no direct command in ANSYS Workbench to determine the law of conservation of energy. So what we will do, we will determine the total heat flux going into the system equals to the total heat flux going out of the system. If these two are balanced, then we will obtain the required result. We will again compare the results of heat flux going in and the heat flux going out. Now we will move on towards ANSYS Workbench software to perform the FEA analysis. This is your ANSYS Workbench window. Here, these are the analysis systems, just like we have done previously in last 10 episodes. Today, we will select the steady state thermal analysis. Double click on it. Now this analysis system has been created. Kindly rename it to 2D thermal analysis. After renaming the thermal analysis system, what you can do, you can go into the engineering data by double clicking on it. But first, what you have to do, you have to simple click the geometry, do not double click on it, and right click on it just like this and select the option properties. You have to perform this step at the start of your experiment just like this, and this window will pop up. What you have to do, you have to change this analysis type from 3D to 2D. Do not do this step after performing the geometry step or model. It will unstable your analysis system. Do this step at the start of your analysis system. Now we will go into the engineering data and will select multiple materials that are available in the ANSYS Workbench window. It is loading the ANSYS engineering data properties. By default, structural steel is selected whose thermal conductivity is given. Simple click here in the engineering data sources and select the category of general materials and select multiple materials as per your requirement. I am selecting stainless steel. Structural steel is by default selected. I am selecting also titanium and grey cast iron. Click here again. These are the materials that we have added in this analysis system. Kindly close this engineering data tab from here and right click on the geometry. Do not double click, only right click and select new design modeler geometry. It will open up the ANSYS built-in CAD software where we will define the geometry. You can also import your geometry from other softwares depending upon your requirements. As you can see, the ANSYS design modeler window has been opened. Kindly click on the XY plane and select this look at command from here. It will convert the 3D axis into 2D axis. Go into the sketching window and select rectangle and select the origin as the starting point of this rectangle and the ending point at an arbitrary distance like this. Now we will specify dimensions and select this line and place the dimension holder by simple clicking here, which will create a dimension holder of h1. Similarly, we will create a dimension holder for this vertical line, which is v2. Specify the dimensions of h to be 2 meters and v2 to be 1 meter. After specifying this, kindly go into the concept and select surface from sketches. We will convert this rectangle into a surface. In order to select the sketch, kindly click the XY plane, this plus sign and sketch 1. Click apply and press generate. Now this gray region represents your rectangular plate which is oriented in 2D. There is no need to specify thickness because we have already told the system that it will be a 2D analysis. Now close this window of design modeler. Our geometrical step has been completed, which can be identified by this tick mark sign. Now double click on the model tab to start the ANSYS mechanical window, where we will specify 3 things: mesh, boundary conditions and the results required. As this window starts up, we will perform these steps step by step as the hierarchy of the ANSYS free outline. The ANSYS mechanical window has been opened. It is loading the geometry that we have created in the previous step. As soon as it loads, we will move forward. Here, the 2D plate is shown. The geometry tick mark sign shows that we have successfully defined the geometry. Now right click on the mesh and press generate mesh. It will divide this surface into a finite number of elements like this. As you can see, these lines are not exactly vertical, So in order to make them exactly vertical, what you have to do, kindly right click on the mesh, go insert and select face meshing. Select this face and here click apply. And now again perform this step by right clicking on the mesh and click generate mesh. Now the lines has been successfully converted into exactly vertical. Now we will define boundary conditions. For this purpose, right click on the steady state thermal, insert temperature and select the selection cubes, which is edge selection, and select this edge. Click apply and enter a temperature of 1 degree Celsius here. After doing so, right click on the steady state thermal again, click insert and select this time convection and select this edge, click apply, enter a film coefficient of 5 watt per meter square degree Celsius and the ambient temperature to be 0 degree Celsius. Now after defining the boundary conditions, right click on the solution tab, click insert thermal temperature. Similarly, right click on the solution tab again, select insert thermal total heat flux and then again insert thermal and directional heat flow. After doing so, solve the model by clicking on the solve button. Now the model has been solved. Kindly click on the temperature button and you can see this temperature distribution. This will be the hot end and this is our cold end. Similarly, by clicking on the total heat flux, you can see the temperature heat flux going in and out of the system. And this is the temperature distribution along this length, which is given by this line. Now our model has been successfully solved. Kindly save the project by closing this window and going into the workbench window and saving by clicking the file save as button. Similarly, create the archive file by clicking here and your model will be solved. The results of your model can be seen in this table, which shows the total heat flux going in and the total heat flux going out of the system. Thank you very much. If you have any questions, you can comment below. Kindly subscribe the channel for more recent updates. Thank you very much.